In this video, we will learn how to differentiate a parametric equation which is based on a trigonometric function. So let's look at the first question. The first question says x is 2 plus sine theta, y is 3 minus 4 cosine theta, and we are interested in finding an expression for dy by dx. Now we know that x is 2 plus sine theta, dx by d theta, derivative of 2 is 0, derivative of sine theta is cosine theta. Similarly, y is 3 minus 4 cosine theta, dy by d theta, derivative of 3 is 0, minus 4 remains as it is, derivative of cosine theta is negative sine theta. So this expression simplifies to 4 sine theta. When we have x in terms of theta, we get dx by d theta. When we have y in terms of theta, we get dy by d theta. Remember the application of chain rule. Dy by dx is equals to dy by dt divided by dx by dt. Now initially we were having t as the parameter. Now we have theta as the parameter. So modifying a bit, we can write dy by dx is equals to dy by d theta divided by dx by d theta. This is dy by d theta, which is 4 sine theta. This is dx by d theta, which is cosine theta. So therefore we have 4 sine theta divided by cosine theta. We have the knowledge from trigonometry, sine over cos is tan. So we are left with 4 tangent theta. This is the expression for dy by dx. Let's look at the second question. We have x equals to 3 sine theta, y equals to 5 cosine theta. We are interested in finding the equation of normal at the point where theta is pi by 6. First thing first, when theta is pi by 6, the x coordinate is 3 sine of pi by 6, which is 3 multiplied by half. That is the value of sine of pi by 6. This simplifies to 3 over 2. Similarly, we have the y coordinate, which is based upon the parametric equation 5 cosine theta. This is 5 multiplied with cosine of pi by 6. This is 5 multiplying with the value of cosine, which is cosine of pi by 6 is root 3 over 2. This simplifies to 5 root 3 over 2. Therefore, the coordinates of the point at which theta is pi by 6, the x coordinate is 3 over 2 and the y coordinate is 5 root 3 over 2. Now what is left? We are interested in finding dy by dx. Remember, that is the gradient of tangent to the curve. So first of all, if I look at the question again, x is 3 sine theta, y is 5 cosine theta. So x is 3 sine theta, y is 5 cosine theta. Differentiating x gives us dx by d theta is 3 cosine theta. Dy by d theta is giving us 5 into negative sine theta. In other words, dy by dx is dy by d theta divided by dx by d theta, which is negative 5 sine theta divided by 3 cosine theta. Change sine over cosine into tangent of theta, which is minus 5 over 3 tangent of theta. Now remember that we have to plug in the value. So we know that theta is pi by 6. dy by dx is negative 5 over 3 tangent of pi by 6. And the value of tangent of pi by 6 is 1 over root 3 in the unrationalized form, or root 3 over 3 in the rationalized form. Let me use this value 1 over root 3. So this is minus 5 over 3 into 1 over root 3. This is the gradient of tangent. Therefore, we are interested in finding equation of normal. So if we are interested in finding equation of normal, we have the x coordinate, we have the y coordinate, and all we need is gradient of normal, which is negative reciprocal of gradient of tangent, which after simplification, this expression will get flipped up. So gradient of normal, first of all, it will be positive. 3 root 3 is at the top and 5 is at the bottom. So we have 3 root 3 at the top and 5 at the bottom. And now applying the equation of a straight line, y minus y1 is equals to mx minus x1. Therefore, y minus the y coordinate, which is 5 root 3 over 2, is equals to m3 root 3 over 5 x minus x1. This is the equation of normal to the curve at the point where theta is pi by 6. Let's have a look at this question. The question started with two parametric equations, a pair of parametric equations. We are interested in finding equation of normal at the point where theta is pi by 6. When theta is pi by 6, this is the x coordinate and this is the y coordinate. And then what else is there? We are interested in finding dy by dx, that is for finding the gradient of the tangent. So first of all, applying the chain rule, x in terms of theta, after differentiation, what do we have? Dx by d theta. Y in terms of theta, after differentiation, dy by d theta. dy by dx is y at the top, x at the bottom. We get 5 over 3 with a minus sign, tangent theta. And what else do we have? We have the plug-in value, which is pi by 6. In dy by dx, we find gradient of tangent, negative reciprocal, that is the gradient of the normal. Joining all the dots, what do we have now? We have the equation of a normal, we have the gradient of the normal, we have the x coordinate and the y coordinate that was written above, and hence you find equation of the normal. Let's look at the third question. X is in terms of theta, y in terms of theta. Find the values of theta between 0 and 2 pi, for which the tangent is parallel to x-axis. First of all, whenever we have to solve a trig equation, it is necessary a range of values of theta will be given. In this case, it is between 0 and 2 pi inclusive. Second thing, we are looking for the concept that a line, which is the tangent line, is parallel to x-axis. When a line is parallel to x-axis, the gradient is 0. What is the gradient of the tangent? Dy by dx equals to 0. So this is the strategy that we will use. We will work within the limits between 0 and 2 pi inclusive. Tangent parallel to x-axis, it means from coordinate geometry, gradient is 0. What is the gradient of the tangent? Dy by dx, we will equate it to 0. Now let's start the working. X is 2 cosine theta. Therefore, differentiation will give us dx by d theta is minus 2 sine theta. Similarly, y is sine theta, the whole thing square. That is what is meant by sine square theta. Therefore, dy by d theta, 2 comes down, sine theta remains as it is, power reduces by 1, Don't forget to multiply by derivative of bracket, which is cosine theta. This is also application of chain rule. What do we have till now? Dx by d theta is negative 2 sine theta. Dy by d theta is this expression 2 sine theta cosine theta. Now let's simplify the working. Therefore, we have dy by dx is equals to 2 sine theta cosine theta. The y expression goes at the top and the expression for x, the derivative expression, negative 2 sine theta goes at the bottom. Simplification gives us dy by dx. The sine and the sine cancels off, the 2 and the 2 cancels off, and we are left with negative cosine theta, a simplified expression for dy by dx. Now, we have to equate dy by dx to 0. So dy by dx equals to 0, negative cosine theta equals to 0. In other words, cosine theta equals to 0. And we are working for the range of values, the set of values between 0 and 2 pi inclusive. Now, how to solve this part? We have to draw the x-axis, and then we have to draw the y-axis, and we have to draw one cycle of cosine which goes up like this. So now let's label it. This corresponds to 2 pi. This corresponds to 0. The maximum value is 1 occurring at 0 and at 2 pi. The minimum value is negative 1 occurring at pi. What else is there? There are two roots. Roots means the x-intercept. This is pi by 2. This one is 3 pi by 2. And the answers for this equation is based upon the graph of the function y is equals to cosine theta between 0 and 2 pi. Therefore, the answers are pi by 2 and 3 pi by 2. These are the values of theta for which the tangent is parallel to x-axis. They are asking us find the values of theta. If they would have asked us the x and the y coordinates, we'll plug in the values of theta in these two equations and we'll find the corresponding x and y coordinates. So what have we learned in this video? We have learned once again how to solve the differentiation of parametric equations based upon the concept of chain rule. And what exactly is the chain rule? Dy by dx is dy by d theta divided by dx by d theta. And we should also be aware of the fact that dy by dx is gradient of tangent and gradient of normal is the negative reciprocal of gradient of tangent. And we have applied coordinate geometry to find equation of line, which could be equation of tangent or equation of normal.